Day, students. I hope you're all doing well. So, today we'll be looking at just simplifying these algebraic expressions. And in essence, these are actually division, right? Dividing. So, we're looking at division as well, partly. And we are just going to apply what we've been doing just to this final section that we have on algebraic expressions. So without further ado, let's go. So we have 4x squared minus 25 all over 2x minus 5. Now, is anything that we can that's significant that we can do with what's at the bottom? I don't think so. So let's move the top. Now, what do we see? Well, remember what I said about difference of two squares, right? 4 is a perfect square, right? X squared, a perfect square, also 25, right? Why? Because when we put them under a square root, we get a perfect, like a natural number without any remainders. We get just a perfect number, right? So what we have on top is a perfect, we have a difference of two squares. And how do we go about with that difference of two squares? Well, we just put this over there, put this over there, and put the square root over there as well. That's just it. So we have 2, square root of 4 is 2, square root of x squared is x, and we have to put a minus or positive here, but I'm gonna just put a minus first. Square root of 25 is 5. Now on the second bracket, same terms, 2x, but now we have to put a positive. Why? Because positive, a negative and a positive leads us back to this negative, right? And then we have to put a 5 again over this side, and then we have 2x minus 5. Now, what do you think we should do next, by just looking? Well, we separated these. This difference of two squares, we have two brackets, and what we have here is the same as what we have over here. So what we can do is just cancel it out, and then our final answer is 2x plus 5, and that's literally it. All of this work that's been doing is just led up to this point, basically, whereas like we're just applying the concepts that we learned, and then we just put it into one. Next question. We have 9x squared minus 49 all over 3x minus 7. Now, is there anything significant that we can do with what's at the bottom? No. But if we look at the top, same thing. 9 perfect square, x squared, also 49. So let's just put these for ourselves, right? You don't have to, you mustn't write this down as a part of your answer. You can just do it on the side, right? And then we know that the square root of 9 will give us 3. Square root of x squared is x. Put a negative here, square root of 49, it's 7. Again, same numbers, put them on this side. Now we just have a positive, and then we have our 7 again there. Difference of two squares, this is how we do it. I'll put a line there, and then write this again. Then what do we see? We see that this, what we have over here, can cancel with what's at the denominator, and then we are left with 3x plus 7. That's basically it. Last question. There's not a lot of explaining here to do, but rather there's just like you see where the work that we've been doing, like how is it still relevant to these kinds of questions? Difference of two squares, factorization, and all of that. You know, how is it still relevant here? Yeah. let's move on. 3 minus 3x all over x squared minus 3x plus 2. Now, what's different with this one? It's 3 minus 3x. We see that 3 and the 3, we can just simply take it out, all right? But like we first want to see where this trinomial will lead us, all right? So let's close it up. Okay, let's close it up. We know that we're supposed to have two brackets at the end. Okay, and what do we have here? We have a positive 2. Okay, so and we have a 1 here. Now let's go back to this positive 2. 2 only has factors of 1 and itself, right? 1 and 2 only. So, and we know that when we multiplying 2 and 1 gives us 2, but adding 2 and 1 also gives us 3, which is what's here. But wait, let's look at the signs. This is positive, that's negative. So surely it was negative 2 minus 1 that gave us this negative 3, because negative 2 times negative 1 gives us positive 2. And negative 2 minus 1 gives us negative 3. So we got our terms that will become our loss essentially. And so we know that we have got to have a negative 2 and a negative 1 over there, and then we just bring in our x. Okay, just bring in our x. Now, can we cancel anything? I don't see anything that we can cancel. All right, and that's why I said let's just figure out what's at the bottom. Let's just get it over and done with, then we can come back here. Okay, and then what do we see? We see a 3 on this term, 3 on that other term as well. So what we can do is take the 3 out as a common factor, and then what are we going to be left with here? We're going to be left with a 1, and on this side you're going to be left with a negative x. Okay, this is all over x minus 2, x minus 1. All right, got a bit distracted, so let's move on. However, if we look at this, we can't cancel anything here because this one is positive, the x is negative. Here, the x is positive and the x is positive and the 1 is negative. So we can also take out the negative, all right? The negative here. Therefore, here we'll have negative 1 and a positive x, and then we have x minus 2 and x minus 1 again. Now, what can we do? We can cancel out these. That's negative 1, x, x. So they're the same. We can take them out, and then we are left with negative 3, x minus 2. What you could have done from the beginning, you could have taken out the negative 3, then you were going to be left with negative 1 and a positive x. How does this work? Because when I multiply this negative 3 back into this bracket again, negative 3 times negative 1, that's positive 3. Negative 3 times negative x, negative 3 times positive x, that's going to give us negative 3x. So we just took out a negative, because if you multiply it back again, it will lead us back to this expression on top. And that is it for today.